Hey, how are we doing? It is time to do some afternoon statistics. Anyone here? I saw there's two people watching. It might have just been me watching on both computers. I've got some cool stuff to start off here. I ran this in the background while I was getting the stream ready. So at the end of class today, I was like, I know we can tune the trees. I am like, I am not hallucinating. I have tuned trees before. I know it. And so we're looking at Jump Pro in the background right here. And so if we open up some project data right here, let's open up this project data. Let's open it up. We can do things where we can go to, I believe, I don't do many graphs in Jump anymore much. Watch me, good. We seem to be having broadcasts where we're doing well. Partition model, there's bootstrapped forest, so that's a forest, and there's boosted trees. So you can see where you can go here and you can pick the, where are we at? Bootstrap forest, there we go. And it should let me pick the number of trees in it. I've seen Jump do this. Maybe they changed Jump also. But here, I'll show you what I found also. And here you go, boom. But I don't think you get a tuning grid. It might be hard for you to see. You can choose your number of trees, number of terms sampled per split, bootstrap resample rate, min splits per tree. That's like min nodes per BIOS, max splits per tree. That's splits, min split size. That's min observations in node, and multiple fits over a number of terms. Suppress multi-thread. I don't even know what suppress multi-thread does. Oh, we got a random seed right here, so we can like get the same results. It looks like, and it's going to make 13. There we go. Number of rows. So yes, so that's how Jump does it. We don't do it in Jump though, but I found some code. I found the code. Here's the code I found right here to make a custom random forest. And because I was like, I know I've done this. I mean, I did in Jump. I've done it in other programs. I think I did it in NCSS, which is a program Dr. Seaver uses. So if you ever took Dr. Seaver, but people probably, no, I miss Dr. Seaver. He's still around. But so you see right here, we've got the parameters it's fitting. These are the tuning parameters, mtry and entry. And so we go right here and we've done it. We've set up our tuning parameters right here. And so we are going to tune that we have 3 different mtries. And I haven't plotted this yet. Please plot. Please plot. Could not find function ploy. There we go. Look at it. So beautiful. And it was going off the edge of the graphic right there. Here, we'll zoom in on it. So we're trying to maximize accuracy. And if you notice, we are actually seeing lower accuracy with more trees. What's up, Adam? Look at it. We've got the 2 tuning parameters. I said you could tune. I was like, I am not wrong. Remember the day with the ROC AUC? We'll call it the crazy ROC AUC day. I mean, everything I said was right, but I was like, what's up, Lexi? Good to see you here. I was like second guessing myself, and I was like, I'm doing it right. I swear. What's up, Kelsey? And so I am broadcasting right now, right? Can you hear me? Give me a yes that you can hear me. Every once in a while, we should be broadcasting. Yes, cool. I looked at the stream right there. There's these days where I'll be broadcasting and I'll be talking for a while. Hey, Anisha, if you remember at the end of class, I said you could tune those trees, and look at that. We have now tuned the trees. I can post this code for people if they want. Let me save it. Let me go to this file, save as, custom RF tuning. So I added a block of code into here. I did not write the code all by myself. I found where it was at because I was like, I know we can do this. I've seen it done before. So this creates a custom random forest method. And if you notice, the method's no longer in quotes because it's like an object in the global environment. So this does allow you to tune on that. I mean, when there's a will, there's a way in coding. So now what's interesting though is, and we can maybe let this run in the background real quick while we look at some other stuff. Well, and then ask questions if you have about the homework. I got some really cool things to show today. I've just been doing work in the background. See, this is the problem, is I start like looking up things, I start coding more, and then I'm like, I gotta finish writing the exams. I gotta do this. I gotta respond to this. I gotta write this. I'm writing a grant right now. I'm writing another grant. Like I'm like, okay, gotta do this, gotta do this. And then I'm like, oh, it's 10 p.m. at night. Gotta go to bed. Or okay. So once again, this relates totally to 474, but if you look, how many models is Brian creating? 474, how many models has Brian created? You should be able to look at that tuning grid right there and figure out how many models. Like these are quick text questions. And if you're in 320, you're watching this, you should be like, how do they know that? Because there's 3 mtries. You are right, Adam. That's 1,000 office hours points. Whoops. There's 3. Yep. Anisha, you know how to do it. You got it. Yep. We practiced this today a little bit. It becomes one of those questions where you're like, oh, well, there's 3 values of mtry, which is the amount of variables we will select. And then the entry is the number of trees we will use to make this. So there's 9. We can confirm this by looking over here. You see, boop, 1, 2, 3, 4, 5, 6, 7, 8, 9, and these are the values of m trie, which stand for the number of x variables that are being used in each tree. And then we see here the what is this? The number of trees. So the different color lines are the number of trees. And I literally was just sitting here trying to make this code work. But yeah. So this is what's cool is like I was like, I know we've done this. And I was like, I'm gonna show them that it can be done. Some people can write in the review like, he doesn't even know what the tuning parameters are. I swear I know what the tuning parameters are. They're just knobs that we can turn. They're just knobs we can just do whatever we want with. But something really cool, I'll say his name if he wants. I'll ask him, but this is code he sent me to kind of look at. I'm going to move that chunk a little further down. So this is all the COVID-19 stuff, and there's this, I'll ask him if he's, so I don't want to take credit for this work. One, I want to say thank you to a former student who is really big into data. You can look at all of his packages right here that he's loading up to start. Do I have all of these? Apparently I do have that one. It's cool when you load these up now that it says like you don't have this package. So if you look at what he's doing, he's going straight to the TN.gov site and he's reading in the URL. So this is read XL. So this, I don't use this format so often, but the way he's doing this right here is there's a function read XL and he's calling the package. So truthfully, what we might do, he's doing the read XL that way. It should work also. It should just work if we do this. Let's give it a shot because we already have read XL loaded. Okay, cool. That just literally went out to the web and downloaded that file. Read XL. Is it not read XL? Sure. I don't use this format as much. Read XL and read XL. Sure, it works. Yep, there we go. Error. Uh-oh. Uh-oh. What did I break? I broke something. Do you mind sharing this code I'm working on? Yeah, let me ask. Email me Anisha, and I'll see if he's like, I'll be like, hey, I have a student who's this wants to do this, you know, and if you are if he's like, yeah, sure. A lot of students are like, yeah, sure, share it. Dad, I could not have just broken this. Really? It's working on my computer. Error evaluation of zip cannot be opened. What? Well, this was working on my computer a moment ago. Download file. It's downloading the file. Equals temp. Is it not data.url? See, it's saving the URL. It's going there. Dest file equal temp. And the read XL. Maybe that's the problem. I was doing this on my computer. Do I not have read XL on this computer? That might be the issue. Well, did I not load all these libraries? Okay. I think we found the issue. Brian didn't load his libraries. I think we narrowed down the issue. Or we didn't. It's working on GitHub and SAS have great data sets for COVID. Yeah. And I really like that. I was going to show everyone the graphics. Maybe I just need to email it to myself. What's up, Jordan? Start asking questions. We're just kind of looking at some data right now. And we're just seeing how R can literally go to the web. Error evaluating. Literally, well, the way it's set up, hopefully I didn't like change anything, is you should be able to just run everything. You see it's just running into errors. Ask questions. It worked on my computer. I'll see what's going on. Maybe it's because I've gone there too many times now and it's blocking my URL, but I don't use these codes as often, but it's pretty evident what it's doing. It's going to the URL, downloading the file, saving it as a temp and dest file. Then it should be able to read the temp file and save it as TN cases. Because you can see it's downloading the file. That literally just downloaded the file. So you can see right here, length 19 kilobytes. So it's a little Excel file. It's downloading, but ask questions about your homeworks. Ask anything you've got. I'm just going to see why the code's not working. Read Excel. Why is it not working? See the temp object. You know what? Oh, I know what it is. You know what it is. Oh, you know what it is. It's the working directory. It's always, what's up, Ahmed? Watch this. You ready? Here we go. Watch this. You ready? Boom, boom, boom. Session. Set working directory. Choose working directory. We're in downloads now. And really? Yeah, it's saying it can't find the file. That's weird. You know what we need to do? File. This is the big thing. Literally, this is why I tell students. Downloads. It's in downloads. I might close it out. Could you elaborate on what we should store and to improve on the for loop? Yeah. So we did this earlier. Jordan and I were working on, here, we'll hop back to this. I literally have it working on my other computer, and I might have to shut down R and reboot it up to do it. And then can you work on task 3A and 3B? So Kelsey asked that first. Let's do, Kelsey, that's 474, right, Kelsey? Kelsey, is that 474? Feel free to ask questions when Brian's just kind of talking about, he had his 10 minutes of fun. I literally have this code working on my other computer. So assignment 10 right here, tree-based models. Let's see here, 3A. Am I going mad? Here we are down to 3. Which one are you elaborating? Which one are you asking about, Kelsey? You say, can you work on task 3A and 3B? Task 4. You're talking about task 3, right? Let's do it. This right here. And when it produces an effects test p-value, is that the same thing? Yep. Brad, you're totally right. Yep. So there we go. Sorry, all the numbering. I've caused complete confusion. So the purchase data frame of red class contains a small part of a customer data set from bank. Of interest is the variable purchase, which tells us if a customer did or did not make a purchase. So this is huge, Brad, right here. This is categorical, which means we could do logistic on it. On the following 30 days, predictor variables include visits, number of visits that they had spent, how much the customer spends, percent closed, the percent of purchases this customer makes in general that are within 5 miles of their address, close set and closest stores, which detail how closest the nearest stores in the chain is to the customer and how many stores of that chain are within 5 miles of their home. Okay, so we're going to load up the data right here. We're going to take a look at this right here. Cool. Let's take a look at these plots. It's rather, you can look at the distribution of it, and it's rather, there's small amounts in these smaller groups. So if you look at it, the values, if we were to do a histogram of it also, we're seeing that there's a lot of visits between 0 to 5 and 5 to 10. So the data has a very not good structure to it. So you can take, just so you can see what's going on right here. Let's go to hist. And just so we can look at the visits right here, I'm just going to look, and there is a relationship within that, but let's just look at the visits. And let's go right here. And this is what I'm talking about right here. But what we're looking at for the moment is the bivariate relationship between purchases and somebody's visits. And you can see here in these graphics that the more people spend, the more likely they are to make a purchase. And the more visits they have, the more likely they are to make a purchase. This literally goes back to 320 right here. There's hard to see at the end here, but there's a little bit of a non-monotonic relationship. This is 320 logistic regression talks. And you could literally do a logistic regression through this. Like we can take this same, so this is good, like kind of just talking about 320 for a second, even though this is a 474 question. But we're just looking at, with this graphic, how much people purchase and their visits. So we're going to take this exact same line of code. So 320, listen up. And we're going to go here and we're going to go M save into. And 320, what am I going to put at the end of this right now? 320 should know instantaneously what's going to go after this. Something will go after that. And then Brad was talking about this right here. You can visualize the model. And this will go binomial for 320 knows that. And now you can see that the probability of somebody not making a purchase, you got it, Jordan. Nice job, Jordan. So you can literally see the relationship somebody's visits have with them not making a purchase, i.e. two people who differ in their number of visits by 1 unit. The person who, but it's not all else identical because it's not a multiple. Two people who differ in their visits by 1, the person who visits more often is less likely to not make a purchase. If less likely to not make a purchase sounds odd, then just say they're more likely to make a purchase, because this also goes back to 320. The level of interest here, ooh, it must be, the variable must be coded purchase and no. Let's look at the data. It's buy and no, because usually the level of interest is yes, but because this is coded as buy, it's the level of interest is no, because no comes after buy. So that's confusing because usually you think purchase would be yes, no, but purchase is buy and no. So the way they've coded it, the level of interest is no because the level of interest is last in logistic. So interesting structure with the data with what's going on right here, but yeah. Let's try to predict purchase yes, no. We will use the data as is using the set seed, randomly split it 50-50. So let's do that right here. Classic stuff. Okay, so we're gonna see if what sort of RNG manipulation we need here. We can do like some set seed manipulation. The classic stuff we're gonna do here is train rows. You see I've already called the object once, but we're gonna now make our own. We're gonna sample from 1 to the number of rows that exist in the purchase data frame. All this is, you should know what this is right here. This is just a vector of numbers that are all your random row numbers. And then we are going to say what percent we want. So now we have to take 50% of the number of rows. And this right here tells it what percent to take, or like amount. But we put a percent before it. And we have to know how to spell purchase. Once again, doing little things like this can help you understand like what's going to work right here. So this is how many, and this is what we are sampling. A lot of spaces right there, but this is what we are sampling, and this is how many we are sampling of it. So we're sampling that, and we're sampling that many of it. So these are the train rows, and now we go over here and we do train, save into, we go to purchase, and we want to go to the what space in purchase. What space do we want to go to inside of purchase? The what space we're going to go to inside of purchase. What space are we going to take this information from out of purchase? The what space. What space will we take this out of? What space? Just as a Brian, I tried replaying this morning's video. Oh, yeah. Sometimes it takes like a few hours to put the full video on YouTube. So Anisha, it should fully post by like 3 or 4, like maybe right now. Sometimes YouTube takes a moment. Sorry about that, Anisha. It's been decent lately, but no, a few people have emailed me and said, hey, Brian, the video is only 2 hours long. And it'll either start like halfway through or it'll end halfway through or something. And so during the school year, I'm going to try to keep videos under 2 hours. Good. Thank you for asking. 1,000 points right there. I appreciate it. We went crazy with the points. I got to control myself with points. I can't help it. You guys are doing great. Like the people showing up, but like and asking questions and working hard. I really appreciate it. Where's this going to go? Where are we going to take from? Where are we going to take from? Where are we going to take from? What do we sample from? Coffee grounds. That's not what we sample from. Because I need to put this somewhere. I need to go here. Well, it'll go in the what space. Train rows. And where does that go, though? We're going to take, literally, it is what it says it is. It's from the row space. So one error I see people make is they don't put the comma there. So if you don't put that comma there, you're treating it as a one-dimensional object. Rows, yep. Nice job. Everyone, if you're here right now, you're getting 1,000 points. Like Carly and Kelsey and Anisha and Jordan. You guys are all getting your 1,000 for being here for office hours. So we run all the code. One thing you want to do sometimes is run it all together in a block. Let's see if we have the right sort of randomness. And the answer is, oh, my laptop's set up differently right now. We do. Whatever randomness we are using is the right randomness. And if you want to confirm your randomness, RNG kind, there it is, sample kind. I have learned this one. Rounding. I used to have to look at this when I would do it. And that is the right one. So you want rounding. You don't want rejection. No one wants rejection. And yeah, you see, if you look at this right here, rejection turns out a different result. So this is the, I think that'll, whoop. So now this has it with rejection and then rounding. Cool. And then we'll run it with rounding right here. And now rounding puts the same result. What do I mean by same result? We meet the sanity check. What up, Andrew? So good to have you here, Andrew. And we have now made our random subset. We've made our random subset. Based on the distribution of cost purchase, what will the naive model predict? 320, where are you at? 320, I want someone to explain this. Brian's he's gonna get the remainder of his coffee. Explain, and here, you probably need me to do a code. Well, let's do it. Table, sure. There you go. There's the answer. Be right back. Coffee time. Brad, you're close, and Brad, you get Brad, you get 2,000 points. Brad, you're super close. We can do number 5. You bet. Is that 474 also? So Brad, the naive model is the truth. The naive model would not predict this and this though. That you're on the right track. I know what you mean by that though. Like this is the truth. This is who actually bought from the training data. So it's not what the naive model will predict though. What will the naive model predict? I got my apple, got my coffee. What will the naive model predict? How does the naive model predict? This is good for 320 and 474. Something with an M, something with a level. And then everything gets that. No X's. The naive is based on no X's. The naive has no X's. There we go, Jordan, right there. And so it has like, and so Jordan, perfect right track right there. The naive uses no X's and it bases its predictions on the majority class. So the naive model will predict nobody will buy because that's the majority class. Does that make sense? The majority level or class, like we don't mean like class, like type of variable. We just mean like, okay, this is this group, this is this group. Think of like classes like freshman, sophomore, junior, senior. It's like whichever group has the most in it, we just say everything is that because that's the most accurate. So if you want to see how the naive model does on these, you could just realize that we could do this and divide by the number of rows. I don't know if this question asks it, but this is like our activity today, which asks similar questions. What do we do? Oh, we can't do that. And there's that. So the accuracy on the training data is 75.05, and the accuracy on the holdout is this right here. So this is the accuracy. And one really cool thing you can do is you could literally take and grab these numbers like this, because these are the second numbers. You probably want to do an as, wait, that did not do what I wanted it to do. Oh, I know why. Because we don't want that portion of it. We want this portion. So if you really want to go all fancy right here, you can start doing, I think I was showing Brad this, and you could go to unname, and you could go, and there we go. So then you could store this as holdout accuracy or something like this. And then when you're typing down here, you could say, I don't think it asks for the holdout, but you could say the accuracy for the holdout was, and then you call the R element with this, and then you go and you grab this object. So this right here will literally put into your report this right here. And just to show you a quick peek of that, because I think it's so cool. We don't want to do an R script, we want to do an R markdown. Just to see what this looks like, if you were to have that value stored right here, we're just going to put it right here for the moment. And let's go to holdout, and we're just going to store into here, because it will store something like this right here. When you print your report and you go to HTML, random document, you can make your report, and if this is like a weekly report, it would literally go down here and print this. The accuracy for the holdout was this. You could also go and hide your work with this and go to show nothing, run code, and we apply that. So now it says include equals false, but now when we run this, we're going to go to knit, and this is just a way to quick knit. But if you look right here, it'll go down here and it'll say the accuracy for the holdout was this. So we didn't actually write what the accuracy was. We're letting it compute it for us right here. So I've always thought that's kind of cool. And it was some students who showed me this. They're like, hey, you can just have it put in the report for you. I was like, oh, it's much easier. Which is something I'm working on as we prepare for next semester. Like these are some tools and techniques I'm going to have students utilizing, so that way their reports can augment, which I think is just really helpful, because why write the number when you can just store the number and then have it input the number for you? So if you notice right there, the number is already input for us. So let's go back to the model right here. So we should have the estimated accuracy. I think that's on the training data, the accuracy of the naive model on the training data. So make sure to use this one right here. You should get about 75%. Is everyone on board with this? Let's get some yeses in the chat. How is everyone doing? It should be about 75%. That's what you should be getting. Set up the fit control. Awesome. Good to see you here, Carly. Awesome. So we're going to focus on AUC. Is Brian going to try to write by scratch? It's not too crazy. That's just, we're running PRLC. We're just loading the libraries there. So we're just saying, does everyone understand why we load libraries? Libraries, do we learn more about creating reports in the master's program? Yeah, the master's program focuses a lot on writing reports for companies, more software for companies like SQL, Tableau, some Python and R. Like I would say, and I'm always trying to like look in at what the master's students are doing, but you really get a very strong skill set on like working in a company, because one thing we do is we have meetings with like I've sat down and like explained to Pilot, Haynes, and what was the other one? Pilot, Haynes, and there was a third one, Regal. Pilot, Haynes, and Regal. Executives from those companies came and like they're like, "Hi, Brian Stevens. We'd like to hear about what you teach for the undergraduate program." And I was like the representative of the undergraduate program, and they're like, "So what skills are they learning in programming, and what do you expect them to be able to do?" And they were like, "Good, that's what we want." And they'd be like, "Yeah, here's what we focus on. Here's what we expect." And one big thing they said from an undergraduate student is they want you to know and understand kind of like a good overview of coding. Like you're not meant to know every single function and everything and be an expert coder. You're meant to be able to be like taught, and you're meant to, you know, like if you feel like you're understanding the basics of coding, that's what matters. We can't teach you everything, because if you said to someone, "I've been coding for 2 years," I've been coding for like 7 or 8 years pretty consistently right now, and I still make mistakes all the time. So you just get better and better. And I code pretty consistently. Like I code about every other day at least. No, maybe every day. I don't know. I code every 1.3 days, almost every day. And I'm still making mistakes, but it's just practice. It's like playing piano. It's like I've been playing piano for 2 years. Well, okay. Well, you'll get better and better as you play and play and play. So let's set up that fit control. Okay. So fit control is what we're storing into. I already have an object in the global environment, and train control. So train control is the function right here. And this is what's crazy. It's like the train control function is ridiculous. That's why I always go and grab it. Like I do not know everything. I mean, this what? There's so many arguments here to know what they do. And Jordan and I were looking through this, especially with the if else, how it does like a search, and these are the defaults it does. So Jordan and I, a few office hours ago, were looking through the train control and how picking your different method. So I think if you look at the method is default boot. So we don't want method boot by default. We're going to use CV. The numbers of CV, I know it's a lot, right? See, this is good right here. Are you dropping 3 homeworks right now? Yeah, we'll drop 3 because of the bonus. You got it, Adam. We're not going to do repeats because repeats is only for repeated CV. And so it's going to put NA in there first anyways. We don't have to worry. It's going to set that as default. And all these other parameters we can change for it. All these other arguments. Okay. So method equals CV. We're going to use k-fold cross. We want number of folds. So there's our number. How many numbers did it say? How many folds? 5, k-fold 5. And then we need the 2 extra things. We need class probs equals true because it's categorical. So show me some class probs. Class probs, there we go. Class probs equals true. And 2 factor, what is it? 2 class summary. Is that it? I always forget this last one. Someone help me out. 2 class. There, wait. Here it is right here. You see it's summary function equals 2. Yeah, that's it right there. Summary function equals, and we can turn off the verbose editor. That's kind of, yeah. If you don't have the capitalizations, if you don't do the capitalizations, everything explodes. So you have to watch out because one error in any part of this will cause insanity to ensue. So you want to be careful. Where do we do the train rows recently? Ba-da-ba-ba-ba. That's not where we coded that. Here's where we coded this. Wait, 3 homeworks? Yeah, 3 homeworks we're dropping. Isn't it a happy day? Isn't it such a happy day? Let's see if this runs. It runs. That's what we like. So that it's just the ridiculousness of how, yeah, there's the argument. And then, yeah, it's a caret object. You see, then it tries to run it as a thing, but you don't want to put the parentheses. For both, I believe, because we put bonus assignments. So the bonus assignments will be the additional drop. So the bonus assignment will be the additional drop. So there's 3 dropped for both. Not my intentions, but I can't give you an assignment where we haven't covered it, but I can make it a bonus assignment and I can drop an additional assignment. I'm sure the grade will be very happy with the more grading. So, good job, Lexi and Brad right there. So, wait, we haven't done anything yet. We just ran. Okay. So, we're going to make our model right here on the same line. Okay. And then we got to run our model. We got to run train. Okay. Fit a logistic model. Ooh, 320, listen up. Logistic model with all the predictors, no interactions, and report the estimated AUC for the generalization and the standard deviation of the estimate. Note you'll get the warning metric AUC. Our accuracy was not used. ROC will be used instead. And this is exactly what we want. Cool. And so we're doing, I think, are we just doing logistic? I think we're just fit logistic. So logistic is going to be GLM, which stands for generalized linear model, which it's just like the general set of all models. We saw this today where we had GLM and LM. LM is a linear model and GLM is a generalized linear model. Should show us it right here. Show us the GLM. And there's the GLM right there. It's for generalized linear models. It by default goes to Gaussian, so you can see the default is family equals Gaussian for 474 who's been practicing functions. If you don't put anything in, it's Gaussian, which is just the same as a linear model. So linear models are all family Gaussian. What's going to show us doesn't say the Gaussian though. So linear models are all Gaussian, but the GLM will, Caret's smart enough to know. That's why we like Caret. You can literally just call it M. You know, it makes more sense to call it like GLM for a generalized linear model. Or you could say GLM.logistic, and sure, let's go GLM for funds. Does that mean you could do GLM? Yep. Isn't this so much better, Brad? Because now you just go train. Start us off here, 320 or 474, 1,000 points first person. You can add it on to your 1,000. What's the first part of this thing right here when we do our function? We should know this, blank, blah, blah, blank, blah, blah, blank, blank, blank. What is the first part of writing this? This is good practice, Brad, for 474. You'll be like, wait, this is what we do in 320. Oh, I miss doing 320, 474 back to back. Because the people who come out of look at Brad is doing it right here. Brad's already got it. So, and Andrew and Brad, they each get an extra 1,000. They know what's up. We're doing y tilde x comma data equals. And we're going to do the dot because we're doing all of the variables. Because this is going to do a variable selection for us. It's going to look through and find the variables for us and create the estimates. And we are doing k-fold cross-validation, which Brad will tell you more about that in 474, because you have to know what this is doing, because that's going to fit the model with the bias variance trade-off. So that's a huge thing right here. We're predicting purchase, right? Yep, we're predicting purchase. So purchase, tilde, dot, comma. Now, the reason I'm doing this, and you got to make sure to use your train data. Ooh, I hope the grader takes off. Sorry. I hope the grader takes off a lot of points if people don't use that. We don't have a tuning grid, but we do have a, oh man, I always forget, TR control, right? And then you have to do TR capital control. So that's where the typos equal fit control. I'm trying not to copy paste today. I'm like, I am not going to copy paste. Oh, see, that's why it got mad at me and wouldn't autocomplete. Let it autocomplete if it will. Really? You don't want autocomplete today? Okay. And, oh, we need preproc center scale. So preproc has the, see, this is what I don't like. This is why I copy paste. If you wonder why does Brian copy paste, is that preproc does not capitalize it. And then you have to know that the center, center and scale don't have capitals. I've seen so many people, do copy paste. Please do copy paste. I think everything's going to run right here. I'm just practicing not copy pasting today. And it's just that preproc has the capital P, TR control has the capital C, fit control, we could have named it something different, but we gave it the capital right here. But TR control looks like that, preproc looks like this, center scale has to look like this. It won't spit out an error to you if you, okay, it's working. But wait, oh, we get the general warning. I was like, red, we see the red. You know what you can do? You can go around here and go suppress warnings. Don't give me those warnings. Don't do that. I don't care about those warnings. Cool. Now we run it and it's like, oh, look. Oh, no, nothing. Everything's fine. No errors, no madness. It's not an error, it's a warning. It's just trying to alert you to something, but I suppress the warnings. So especially if someone's freaking out and being like, what does that mean? It's just telling you it's using accuracy instead of ROC. It's all good. It's all good. I need to drink more coffee in the morning. And so what do we got going on right here? Okay, well, this model right now, just think about what we want to do this. We want to take a look at it. So here's what we got. We got the ROC. We get ROC. We got ROC. We got the sensitivity, the specificity. And let's go here to results. And there's the results. There we go. That's got it. And do we have the right numbers? We get different numbers. Dun, dun, dun. Last three numbers are, let's double check. Does anyone see anything off with what I've written right here? Do we have the right, let me look at our train again. I'm going to go back and look at the train to make sure we're using the right train. That is the right train. Let me look at what we did here. 5-fold cross-validation. Set seed. Did I not run the set seed? Oh. No, I think it's the set seed. Only when you're doing assignments, you have to worry about set seeds. So that doesn't matter there. We want to put the set seed on this. And I don't think the suppress warnings will change anything. Oh, it already, yeah, it's logistic. It doesn't take but a moment. Set seed. It was the set seed. We're on the right RNG kind right now. We're playing on the right Xbox or PC, but it was the set seed. So I was like, I don't see anything wrong with the code. We didn't do anything wrong. We just didn't replicate the result it wanted us to replicate. Does that make sense, Jordan? Like, there was nothing theoretically wrong with what we did. We did exactly what the problem wanted. We just didn't replicate the randomness it wants us to replicate. So everything was fine. Everything's fine. You know what I need? Oh my God, I gotta make this. Where I say like everything's fine and like a fire starts behind me. Like whenever I make an error or something's going wrong or my mind's just like I'm losing it, I hit the button, like my extra credit button here, and I'm like, everything's fine. Everything's fine. And like I've got like 3 levels of it. Like the fire just gets worse and just like the whole screen starts just like smoking. I could do a smoke effect. I know, right? Everything's fine. Like everything's fine. I think, okay, I gotta put that note down. Please someone remind me. Yeah, I know, right? Relatable for this week. Everything's fine. Everything's fine. This is fine. I need that. I need to do that. That'd be a really fun one. I don't use my extra credit button nearly enough. I made that one. That was nice and easy to make. Yeah, exactly. That's exactly it, Jordan. That is so classic. That is the classic. That's like the theme of 2020. Everything is not fine. I have so many ideas. I know. You got to send them to me. We need to make a list of ideas, Andrew. Dennis, if Dennis is here, we could have a channel like streaming ideas. And Dennis, we're really going to work hard towards the end of the summer. I don't think Dennis is watching, but we're going to work hard to get the Discord to be as big as possible. So you guys feel free to help out. And once again, thank you. We're Stat Nation. We're just here to support current and future students. And once again, when we get Twitch going, if you join up with Twitch, oh yeah, so yep, let's take a look. What answers are you getting, Vedrina? What are your last few numbers right here? This is, do you see any, check your train, make sure you're getting the same with the train. Like go to train, and first thing is make 100% sure. Go to your train and make sure you have the same answers that are on the screen here. Is this 100% accurate for you here, Vedrina? Is that 100% right here? Are you getting the same exact answers right there? Are those answers identical right there? If they're not, we can fix it. Be like, those are identical, those are not identical. Because it's probably, okay, that's the issue. Here, put this at the start of your chunk and then run your chunk. That should fix it, and then that might fix the later problems. Give that a shot, put that at the start of the chunk, run that at the start of the chunk, and we found it. Oh, you didn't do that. Yeah, so yeah, just here, that's not the heart, this is the heart. There you go. Put that in there right there. And once again, it's important to know what these codes are doing. We write these codes a lot. That's selecting random train rows, and then make sure you sample from your data set the train rows and not the train rows. So we got that right there. Double check back with me if anything's wrong. We'll fix it up. We talked about the predictions right there. We got just the GLM. Set up RPark grid to be the result of running expand grid to the sequence of a CP, blah, 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 blah. Okay, so what CP is, and we're going to talk more about this tomorrow to start class, but CP is the complexity parameter, and it controls how much of a return we need for us to split the tree. So think about this. If I say you get to continue playing a game as long as you you get 1 point in an hour. Like you're playing basketball, and you continue playing basketball as long as you get 1 point in an hour. Who thinks, how long would you probably be playing basketball for? So if I say you can continue playing basketball as long as you get 1 point in an hour, a very long time or a very short time? You'll be playing a very long time until you pass out. You're bowling all day. I like that right there. A very long time. Because that's a very, very low complexity parameter. It's how much you need of a return. The complexity parameter is how much you need of a return to continue on. And just imagine you're playing basketball till you're exhausted. I mean, at some point you'll just be like, I'll be like, you got to make 1 point. You'll be like, ugh, and then you'll like fall asleep and like you'll be like, okay, I played basketball for 30 hours, Brian, then I passed out. But what if I said you can play basketball as long as you get 80 points an hour? Well, now you might only play for like 2 hours because that's a very, very large complexity parameter. Because I'm saying you need this amount of return to continue on. And how does this relate to the tree? Well, the complexity parameter tells the tree when to stop. If the tree cannot get a certain return, it stops. So if the complexity parameter is very, very small, the tree will be very, very what? Just think about the 1 point you need for an hour. If the complexity parameter is very, very small, then the tree will get very, very what? This is a good theory to know. If the complexity parameter is very, very small, because it's how much of a return do you need for the tree to split? Boom, Carly, that's another 1,000. I'll pay your 1,000 for being here today. The tree will get very big because you're saying how much of a return do we need? Oh, dude, I know what you're talking about. I'm so excited for Texas. I'm so excited. Just I'm so excited. My fiance's like looking at desks for me and so nice. Like she's doing so much work. I don't know. So we will have class. We'll do some material, not too much, but we'll do like a little material. We'll like finish it off. I'll answer questions because 320 is way ahead. I could have almost done model building with 320. 320, we'll finish. And then we're doing the Kahoot on Wednesday, you bet. And the Kahoot, once again, will focus in on a lot of the big questions. And so when does the midterm open up? Tuesday night at midnight. And so I've got 320 done. No, I've got 474 done. I've got 474 done. I just don't have. It'll be open all Wednesday and all Tuesday. Or not all. Oh my gosh. It'll be open all Wednesday and Thursday till 2 p.m. And then Brian will be driving all Sunday to Texas. Brian will be all Sunday drive to Texas. So we're going to raise 10 to the sequence of the power of this. So we're going to make an expand grid. Not expand grid. Yeah, that's what we want. So we're going to do a CP right here. We're going to make a sequence of CPs. And so we should be able to do this. CP equals sequence. And the sequence it's going to be is a sequence of 10. Now we're going to raise 10 to the sequence of -5 to -3. But only banner position 2 is shown. Does this imply that banner position coefficient is 0 because it's not listed? Yes, you're predicting, right? If banner position 2 is the only one that's listed, banner position 1 is the reference level, and then the banner position itself does not have a coefficient. Banner position 2, oh wait, I sent you an email, but maybe you can answer a question. One of the following wants me to look at the coefficient of banner position this Sunday, Andrew. It might be talking about that. Let me look at that, Brad. I'll pull up that one after this. Here, Brad, we'll pull that up because I think I want to make sure I address it properly, lest everyone sees me say something in the video it's not. I know what you're talking about. You're predicting whether or not someone will click on an ad, and if it's talking about, because banner position has banner position 1 and banner position 2, and banner position 1 is the reference level, and banner position 2 is the indicator variable. And so the coefficient of banner position 2 represents its difference in probability from banner position 1. If banner position 2 has a positive coefficient, then something being in banner position 2 would be more likely to be clicked on than banner position 1. So two otherwise identical ads where one is in banner position 2 and one is in banner position 1, the ad in banner position 2, if it's a positive coefficient, is more likely to be clicked on the banner position 1. Does that make sense, Brad? I'll repeat it again. Two otherwise identical ads where one is in banner position 2 and the other is in banner position 1, assuming positive coefficient. If the coefficient is positive, the ad in banner position 2 is more likely to be clicked on. I can't go anywhere. I can't bring COVID with me. Texas is already... Yeah, anyways. Okay, but so there's the values right there. Yeah, I'll take a look. Yep, you'll have it. You can have a cheat sheet. The final, basically the final and the midterm are work the same way. I'm sorry, I'm so crazy, Andrew. You like Brian is crazy. There we go. There we go. I know, right? It's driving me nuts. I'm sorry, man. It's I agree with Kelsey. It's ridiculous. And I want to look at the data. We've got the data. One of my students literally was working on all this data right here, former student now, and we'll see if it runs here in a moment. I might reload R. He's looking at all the different, like the average positivity rate between May and June appears to be similar with June. Having much, yeah, he's looking at all this for like, and he's just doing. I think he's just doing it on his own. I'm just like, that's awesome, and I'll see if he'll let us share it. Should have said yes to going out to play pool. I know, right? When I could have gone outside. I'm sorry. Now I can't go outside. The outside world is scary. Okay. We're going to find the optimal value of CP right here. We're going to do an R part fit. And so this right here is just a general tree right here. So let's go ahead and let's do this. Let's go ahead and just go to data mining 3. We're going to cheat. We got this. Here we go. So we're going to go here to, this is going to be R part. And there's the R part grid. And here's the code right here. So we've been doing everything. It doesn't matter what you call it. We can literally grab all of this right here. And we pretty much have everything we need for this question. This makes our lives way easier right here. We're not going to grab our part fit. We already go to that. We want it the way it is. And now we're going to go here to homework. And oh, well, let's not delete the sanity check because we're going to need that. We're going to see if we got it right. We're going to see if we're sane. I think if I highlight all this code right here and do Command-Shift-C, we unblock commented it. That's unblock commenting. So we unblock commented it. Now, once again, we're going to clean up our code, make our code look nice and perfect. We want perfect looking code. Now, there is one thing I have to change before I run this. Once again, please notice the structure where TR control is the capital C. Fit control we've already set up to tune on AUC. Tune grid is not my R part grid. That's the thing I was talking about changing. I call it CP grid. So it's important to know what goes where. Like, you might not use these same name conventions. You should do multiple Command-Shift-Cs to uncomment or comment out. Yep, that's it. If you highlight code and then you hit Command-Shift-C, you can comment or uncomment. And it only does one comment, but because there was a hashtag, it took off hashtags. So if hashtags exist, like theoretically, if you have hashtag and then you have hashtags outside of this, like this should theoretically take down all the hashtags. So if you had a bunch of hashtagged out code, you could highlight it and go Command-Shift-C and just uncomment like that. Yep, exactly. Pretty cool, right? It's just the more you learn, and then you can do this, and you can reformat the code. It's all fixed up. That was Control-I right there. And so this is looking good, I think. Oh. There's one error, 1,000-point bounty on that error. This won't run right now. This won't run. Nice job, Andrew. What's the error on this code? Oh, Carl, you got it. Nice job. There you go. This is it right here, and it's purchase. It's purchase, yeah. It's not. Don't go inside the. Why did I do that? I wanted to see how it was spelled. I was like, it's capital P purchase, right? Yeah. The more shortcuts you learn, just the better you get. Don't worry. Just try to learn one and then use it repeatedly. Don't try to learn them all. Don't be like, I'm gonna learn every shortcut because I've done that. Like when I say don't do something, it's usually I did it and it didn't work out. Set seed. Oh wait, do we have the right set seed too, right? Oh no. Secret 1,000 for Jordan right there. Paying attention. That was a trick. That was a secret 1,000 right there. Cool. That's it right there. I copied it, so I had the wrong set seed. We got that warning telling us that we're using ROC instead of AUC or instead of accuracy. ROC is AUC. So we have this right here. Let's plot this. Let's take a look at the data and plot it. What did we get? What have we done? What have we done? Okay. We got to go down here and look at what we've done. Okay. Cool. What is the right amount of, what's the right complexity parameter? Any guesses on what the right complexity parameter is? What is the right complexity parameter? Right there. That's the right complexity parameter. So the right complexity parameter is the one that optimizes the ROC. ROC is a good thing. It's the way in which we correctly order. And actually, these are horribly ordered. I mean, we give, that's 59.4 or so. 0.593? I'm saying 0.593. Let's take a look at that ROC. Up. 0.594. I should have went with 0.594. I would have been right. And let's see if we got it right, because we did do it correct. Yeah, I like it when we get these things correct. One thing I really like is I like the output lately, and I'm just look at these things. Post resample's good. Is this the one that's been? Oh, haha. I gotta go here and. Okay, I need some votes. I don't know if my fiance has seen The Room. Has anyone here seen The Room? Because I've seen The Room. I'm not the biggest fan of The Room. It's like we're gonna watch some movies and stuff. Like The Room is all right, and I've got The Room, but who's like The Room is amazing, or who's like The Room is horrible? Don't watch it. It's completely ridiculous. I actually met Tommy Wiseau. Watch The Expanse. What is The Expanse? You've never heard of The Room? Wow. Oh man, that makes me old. The Room is like 2011, 2012, like horrible movies to watch. It's the one that what's his name? Oh, what is his name? He played the guy. The bad guy in Spider-Man played him. Never seen The Room. Wow. Okay, I'm old now. Here, I'll run the confusion matrix on this in a second. Oh, wow. That's good right there. So here, we'll run the confusion matrix on this and see how it works. I've just been looking at this confusion matrix. Not that one. Confusion matrix in the carrot package. So you have to look. You've never seen it? Wow, I'm the only person. Give it. What are some movie suggestions that we should watch? Anyone got a single movie suggestion? Any movie suggestion? The Cube is ridiculously stupid though, and that's about The Room. What? That sounds worth checking out. Here we go. This is some things we were looking at in 320 earlier today. Or yeah, we were looking at this in 320. So you can look right here how this does on the holdout, and we can see the accuracy. Ooh, not too bad accuracy on the holdout. Well, wait a minute. Do you guys remember what the naive model did? Oof. The naive model, if I remember correctly, that's probably where this question's going. The naive model, I think it was like 75%. The accuracy here is pretty bad, and these models are just not doing too well. So overall, you interpret those. The Hong Chong creates a decision tree using a different subset of the original, characterize the character's highest probability of buying. I'm looking for some customers who have spent more than 900 and da-da-da-da. So here we go right here. Yeah, because it's just not cool. So with this right here, the following creates a decision tree using different subset of the original data, characterize customers that have the highest probability of buying. So about an 85% chance. Okay. So, and if you're trying to read this, it's on some Prime if you want to watch. If you're trying to read these, you need to go to save, try to figure out the ratio. It works pretty well if you just increase it to something like that. And we'll go to rplot22 for today. rplot22, here we go, and here it is. And when we look over this, sorry, you know what you can do? I'm going to show you a trick. Watch this. You ready? This will be much better. Do I have this right now? I don't right now. Okay. It's Rattle is the package. Okay. So run this line of code right here. Then run this line of code. And then fancy rplot. And then tree. And there you go. And it'll look better when I zoom in. You can... Still going to look like that? Let's do this. Let's do this. That's better. Let's go to File, Save as PDF. It's got about a 2-to-1 ratio, so I'm going to go 10, 5. Go rplot33 today. Our plot 33 and open it up. Oof, no way. You got to be kidding me. Well, at least it's a little easier to read. When you export it, it looks like, why do the windows turn out like that? Ay, ay, ay. Not perfect, right? So when you get down here to the bottom, one thing I like about this is it puts all the terminal leaves at the bottom, and you can also see whether or not people buy. And if you notice, we have that 1% of our customers fall into this group. So I do like this. So sorry it looks kind of crazy like this. Maybe if we, let me look at the other thing. It's probably gonna look better if we just look at it like this right here. It's so hard to read by that. Why does it do that? Was it the way I exported it? Save as image. Our plot, don't crash. Our plot 44. Our plot 44. I've always had problems with large trees. I've always had problems. Two seconds. Always problems with these large trees right here. Q, it's... So, let's see. Let's take a look. We go to save PDF, and let's try what native size it tries. Our plot 13. Lucky 13. Lucky 13. I have no idea what does that. That is just so weird with the rattle package. It drives me nuts. We're looking at this one right here. And... Okay, I'm taking one more try at this. Save image. Let's go to maintain aspect ratio. Nice. 1500. Our plot, lucky 7. Our plot 7. Look at this. It's still blurry. So if we trace down, we're looking at the number of visits. It's going to be easiest to look at in the export. Save as PDF. Sorry, everyone. Yeah, this is the total. It's fine. Everything's fine. Portrait, landscape. Might be better if we do this. 15, 11, plot 77. You can't go wrong with double 7. View plot after saving, of course. That's what we've been doing this whole time. Okay, wait. Oh my gosh. Look at what we did. Look at what we got right here. We got a plot that we can actually look at and read. It's a little spaced out, but I think we can read it. So here we are. We've got right here, we asked the customer, do you have visits that are greater than or equal to 1.5? And the customer answers yes. Then we go down here and we say, what percent close do you live to the store? Your percent purchases, I think, made close to the store. Is it less than 0.73? They say yes. And then we go down to here. And we've got right here, remember which side is the yes and the no. Left is yes, right is no. Just so you remember that if you go to the left, you're saying yes. If you go to the right, you're saying no. And our whole goal is to get down to here. So probably one of the best things to do is to start by going up from the bottom. If you notice, when we asked the percent of your purchases made close right here, what did they answer to this? The percent of purchases made close to the store, is it less than this? The answer is what? The percent of purchases made close to the store. Would they answer yes or no to that question right there? The percent of purchases made close, they'd answer yes. Nice job, Carly. So they'd answer yes, and then we go here. This is how much they've spent. And have they spent more than, greater than, or equal to this? Since they went this way, the answer would be yes. And here's something they answered no to. Was your percent close less than this? If there were an interactive version of this, that would show you the path. Yeah, which they could do that for things like whatchamacallit. See, it's a lot of percent close. The biggest thing is percent close. So it's visits greater than 2, percent close less than, because this one just dominates the percent close. And I would think it's cool if, this is one thing we could update and we could put into Shiny. I wonder, I gotta look at this now. I gotta find out. Is there a shiny decision trees in our, you look up these things and sometimes someone's updated it. Plotting a dynamic decision tree in shiny. Someone's kind of done it. I don't know. They're developing the app, they're saying. And I don't know. Well, we could give it a shot. We'll see what their code does. Can't do anything too bad, right? What does your... Oh, and then the person down here is helping. In your server, try this. I don't know if it worked. Okay. So we'll try their code real quick. Let's just see what happens, because I am very interested. If you saw, that's how we're viewing the tree, and we're just taking a look at what's going on right there. We want to go to Shiny Web App. Let's say tree practice. Single file, cool, and we should just be able to drop their code in. Okay, cool. They had a problem with their server, which this is things we have not covered, and I've only just worked in a little bit. So they're saying there's a problem with their server, and so there we go right there. I think that's, did I copy the right things? Okay, they didn't store into it. That's what this person did. They didn't store into it. They want to do this. Okay, so let's see what happens. Install that. Who knows what? From CRAN server, so it should be all right. Load require shiny. There is no package C50. Cool. Well, libraries. Oh, wait. So did we not install .packages? It's on the CRAN server if it is. Okay. Run app. Up. Plotting a decision tree. Is it working? Oh. Well, that's pretty interesting. So this app right here, if we were to load in the data, so Jordan, take a look at this right here. This is, this is something someone developed for Shiny right here, which allows them to choose different predictors to put in the tree, and then you can generate the decision tree right here, it looks like, and it's making a split there, and it's making a split, so it's got, yeah. So we could put our data into this and have it generate, and I could look at how they're doing this, but you can just choose a subset of predictors right here, and they only have the one target variable, which they're letting you select, and then I don't know how big they're growing it, and then they're seeing the classification matrix. This is a 3-level classification, and this one does pretty well. If you look, if we choose all the variables and we let it generate the tree, it only misses 4. So it misclassifies 4 flowers. So see right here, the error, because this is the 4 errors it's getting, are from the 4 errors right here. It says that classified as, this is predicted. So this is what it was predicted, and this is the actual. So the going left to right is the actual, and these are the predicted, and this is a 3-level classification. And if you were to say, oh, it's 50-50-50, so the naive model would get 33% right, because it would just guess one of the flowers because they all have 50-50. And then it talks about the within kind of the splits right here. And yeah, this is a pretty cool app right here. And this is a person putting out their app, or their little Shiny app. Pretty cool. And then you can see the distribution of the flowers within. So that's kind of neat. Let me vanish for a second. It's kind of neat how they did this at the bottom to see the distribution within each of these nodes right here. I think they're leaving that 1, 2, 3, 4, 5, 6, 7. Okay, cool. So this is 1. Yeah, it says 1. 1, 2, 3, 4, 5, 6, 7. And so when you get down to these bottom nodes, these are the min observations in nodes we care about really, because it can only get smaller as you go down. Like you start off with everything, you split it up, and this was the first split. Like the first split literally was here, and then it split here, and then it split. First split, second split, third split. And it has to be in that order, because this is all the data, splits on petal length, less than or equal to this, and this is the greater than petal length. So this one doesn't even say yes, no. You just have to practice reading them, and this took 0 seconds to complete. It was instantaneous. Yeah, pretty cool output. And, it's just neat that you can select different variables and get different trees and see the different accuracies. Looks like we don't even need all the variables. Oh, 7 misclassifications. Oh, and this tree only split 2 times. Split twice because you have 3 terminal leaves, 3 min observations and nodes. Yeah, really cool stuff. I like that. Oh man, yeah. So this is the kind of things what we're talking about where it's like, I can't teach you everything, but I can kind of maybe pique your curiosity and be like, oh, this is what we could do. Let's take a look at the last little bits of this assignment right here. Homework 10. What else is there on this that we should talk about? XG boost. It's just more tuning parameters. That's all it is. We'll talk about it a little more tomorrow. Which other parts, Jordan, and who else had questions on this? Because we've covered a good bit of that question. We've talked a lot about the theory. And yeah, we went through, and you should be good on this. Ask more questions, whatever questions you have. Here's our R plot. That's the one we're going to use. Did we get the right results? I think we did, right? Yep, we got the right results. And then I was showing how I like the new confusion matrix output that gives you basically all this. Let's see the next part. Feel free to ask a question if you have it. The following chunk creates, oh, and then we went through here. We talked about the different things. Set up a forest grid. Okay. So the forest grid right here is going to try different numbers of mtry. And we showed something at the start. So Jordan, if you missed it, we were able to make it that we can actually make our forest with the additional stuff. So let's go grab our code right here. We've got this nice written code right here. And we're going to take our grid right here, and we're just going to do a little change to it. We're going to drop down here. We're going to drop this in, and then we're going to call this mtry. We're going to call this RF grid. We're going to call this RF grid right here. And we're going to call this random forest, sure, RF. And now we have to change the mtry. I think mtry is going to be the values 135. I think that does it right there. Let's see here, 135, use the training set seed. We're doing that. I think, and it wants to be called forest fit. So sure, we'll call it forest fit, just so we can be consistent with the problem. Once the output is run, can we run through that improvement of the, yeah, you got it, Jordan, you got that. You got it, we'll do that next here. And I think I have everything correct. The determiner should have column CP. Oh, haha, random forest, RF. Thank you for telling me that R. Now we fixed it. So this one right here, we can go back and start grabbing our output. It's creating the random forest. We need to go back and grab these parts right here. We can reproduce them, but this right here is going to just do it all for us. So why not take the code we're given and just go down here and put it in. Now all we have to change, you know what you could do? Watch this. I'm going to highlight the code right here that says all this. I'm going to search within selection, and I'm going to search for our part, and I'm going to replace with that. There we go. So if you notice what we did right there is we just searched within the selection rather than going around trying to find it ourselves. We're just replacing our part with the forest fit. So now we can plot the forest fit. We can do all these things. But once again, what I did was I highlighted the code, got enough coffee today, so I'm like, I got this. We highlighted the code, and then we searched within the selection. So if you search for something here, you can see exactly what you're finding, and then you could just replace with, now don't click there because you'll replace with not what you want. So we found the force fit, and you can always click in, it shows you where it's at. We could remove some of these, and now we're good. So let's plot the force fit. We're going to see what happens with the mtry. How many models are we considering? If you're listening in, 1,000 points. How many different models is Brian considering right now? Boop. How many models are we considering? 1,000 points. You can add them on. Who knows how many models we are considering? How many models are we considering? How many models are we considering? Not in the graphic currently up. Not in this, because this is our CP complexity parameter. You got it. And basically, Vedrino and Carl, you're right. We're considering models with an mtry of 135, which is how many variables we'll be putting in there. And you can see it right here. The optimum level is right here. So when I look at the best fit right now, I'm going to see it selects the mtry 1. So I already know it's going to give me mtry 1 because of this right here. That just says to me, hey, Brian, mtry 1 is your optimum complexity parameter. I'm not mtry. It is literally mtry. So the randomly selected predictors, it's randomly selecting one predictor. Variable importance is going to show us the most important variables. And we were having some fun with this earlier. Let's make it do it. Let's practice. So we could do the plot of the variable importance right here, and we should get it. There we go. And there's not that many variables it uses. So you can look at this right here. The amount people are spending is the most important thing, which we should see that showing up in the trees in the random forest. So when you look at what's most important at predicting whether or not someone will purchase, it's how much they're spending. It's not how close they are to the stores. It's the percent of purchases they make close to the store, it looks like. So it's not how close the stores are to them, it's the percent of purchases made to close stores, and it goes down from here. So really what matters most is if people are going to purchase from us, it's whether or not they've purchased from us in the past and how much they've spent, which kind of makes sense. Like spending leads to purchasing. But also maybe the other important factor is having stores close to them to a certain degree, like the percent of stores that are close. Closed stores might be something like we saw earlier where the variation is already contained in the other variables. It's not important to the tree, so we could maybe remove that. We're getting an error, and because it's the Y. So this needs to be purchase. That might fix it. That did fix it. Just make sure you have in the variable names. It's very easy if you copy paste code to not change the one thing you need to change. And we're getting all the ROCs and all this stuff. These models are still kind of not amazing. Like the accuracy is still 75%. We're not getting very, very good models. And one thing I want to point out right here is, I did say this earlier today, and we'll run this in the background while we look at the next thing, is I was able to make a custom, let's try this, custom random forest. Now you won't have this. I'm going to post, where's it at? I don't know if we were doing this one, but I created this custom random forest right here, and I should be able to go right here. We'll add in the way it likes me to write this. And I think it's entry. And let's go to trees are equal to 100, 500, and 1000. And then we'll do mtry 7 and 9. Cool. There's the random forest grid, and there's that. It's running, so it hasn't broken. And now we are, like I said, tuning on trees. So when Brian said we could tune on trees, we're doing it right there. So this object right here, you'll notice this is not in quotes. This is something I created in the R environment. It's on here somewhere in my billions of output. We're in package caret. And so you can see here the custom random forest it's got all the parameters. You will not have this option. This is a custom random forest. So you would have to send somebody your custom random forest. Oh, and I have it in the other code. Where did I put that code? Homework 10, custom random forest tuning. Here it is. So this is the code that creates the custom random forest right here. You would have to have this chunk of code to put in the mtry and the entry right there and all this good stuff. And it just runs it through and does it for you. So we'll get to see the random forest right here, and we'll be creating way more models. We'll be creating 1, 2, 3, 4, 5, 6, 7, 8. So that's 5 and that's 3. How many models will we be looking at with this? How many models will we be looking at with this? Who knows? 1,000 office hour points. Who knows? How many models will we be looking at? 61.8 or so. How many models will we be looking at with this? 15. Jordan, nice job. Yep. And then let's hop to Jordan's question right here. I was looking at this to see what the ROC was, and it's like at 61.8 or so. I mean, I could go back and... Well, that's on the holdout. So it's at 62%, and it's not overfit. Okay, so we're going to see if we can beat 62%. I'm overwriting my code, so once this runs, which will take a moment. Jordan, which one were you looking at on here? Let me go back to homework 10. So homework 10 is... Where is it? We've already made... Because you're doing the looping, right? So the for loop. So you're on... What? What is going on? Does it say... But it doesn't say for loop? I have gone mad. I have gone absolutely mad. Where is it? Where is it? Here we go. Here we go. So now... Is it not this right here? Am I thinking of the right thing? Define a vector unique x to be the values of... There we go. Sort from the smallest and largest. Okay. So what you're going to do here is you want to go between these values. Define a vector x, unique x, to be unique values of homeowner HAs. So when we go right here, I like doing it between these because I think it just is easier to read. So do it in parts, do every step, like, okay, gotta do this, gotta do this, gotta do this. And you could just call this like defining unique x vector. So if you want to search back through your work, you can find where you define the unique x vector within this task 1 right here. So we're going to take the unique x vector and we're going to go right here and we're going to go to, it says sorted. Cool. So we're going to sort the unique vector of census. Ooh, we don't have census. Here, we'll do it. census, this, and it should go from smallest to largest. We could add in the extra element right here of decreasing equals false, which I think is its default. Because if it's decreasing goes true, it'll be largest to smallest, it'll decrease. And census, this won't run yet because I've got code running and I don't have census loaded up. I think census is just the, I think it's in the, yeah, there it is. Can't run it right now though. You also need, if you're writing this, you'll need library reg class right here because it's a reg class object, and we observe that by doing the following. When you see this, you can see right here it says reg class. So make sure you have reg class loaded up. Don't worry, sometimes people type the code I type, and then, you know, think about what you're doing. Don't just type what Brian types. Be like, okay, do I need this? But, you know, if you think you might need it. And then my trees are just going nuts. We're not stopping it. We're going to run all the trees. Okay, so this should work. Here, let me throw this in the chat for you, Jordan. Do you have that line of code right there? That should store all the unique values of X. So I'm seeing it in my head. Which of these looks like it would be all the unique values of X sorted from largest to smallest? This right here. Which of these could be all the unique values of X sorted from largest to smallest? Which of these could be all the unique values of X? This one right here? Or which answers could be the unique values of X? Answer A, B, or C. Which of these could be the unique values of X? Which of these could be the unique values of X sorted from largest to smallest? Which of these could be the unique values of X sorted from largest to smallest? A and C. Great job. That was the trick. That was the trick. A and C. Because if they repeat, they're not unique values. So these would be, great job right there, Carly and Jordan. Yep. A is unique values. It could theoretically be the unique values of X sorted from smallest to largest. And C could be the unique values also. It doesn't, someone might say, but you skipped a number. Well, it just did not exist. Unique values mean, like, if we talk about people's unique ages in the classes, you might say, oh, there's a 18-year-old, 19-year-old, 20-year-old, 21, 22, 23, 25, 28, 34, and the unique values. It doesn't matter if it repeats. We just count it as a value if it does exist. And that's got that right there. Initialize vectors threshold and prove to be empty. Why don't we do that right here? Okay, someone help me on the chat. How do we initialize blank vectors for these right here? How do we initialize? You can just type the last little bit because I'll just do the last little bit. It wants us to initialize those right here. I'll let you guys do that. Write a for loop that loops through. You got it. Nice job. There we go. That'll initialize blank vectors. I'm still running I'm still tuning the trees. Exactly. Write a for loop that loops through values of I from 1 to length of, cool. Well, that helps us out. Okay, so people tell me how to insert a chunk. What is the quick key for that? I can never remember. I mean, I just always go to that, and there's a quick key for it. You see, there's a shortcut for everything, and I don't know them all. That's such a bummer. So it says we're going to loop through the variable I, and we're going to loop through this right here. So this is going to go from 1 through the length of it. And so we have to be careful here, because what we're going to do is we're going to use certain values here. Store into the ith element of threshold. Okay, so that's telling me I need my threshold vector. Oh, that's done. Okay, we'll look at that here in a moment. So I need my threshold vector, and that's where we're storing. Is that the end of it? Store into the ith element under circumstance a value that is halfway between this one and this one. Okay, so literally we're going to grab this line of code right here, and let's do it outside the for loop for a moment, and let's just plug in 1. So this is how you work a for loop without actually using it. You make sure your code works before you put it in the for loop. So we want the average of these two values. So if you look, and you could just divide it. That works. Wait. You add them and divide them. I don't know how to do, unless I use the mean function, I don't know how to do this. So does this make sense right here? I'm finding a value that's between them by finding their average. So what am I doing? I'm storing 1 into I, and then I'm finding between. Now, it didn't find unique X because we have not run our things. There's that. There's the vectors. And now we have this. And that's between them. We can confirm this because if we go to unique X, we can see the values. And the first two values should be 1 and 2. Oh, see, look, I got tricked. Their first two values are not 1 and 2, but between them is 1.5 because the first unique values are 1.3 and 1.7. What should the third unique value be? What should the third unique value? Who for 1,000 points can tell me the third midpoint for the unique values? Now be careful. The answer is technically 3 to what I just said. But the third midpoint for the unique values, we're going between them. What would be the third midpoint for the unique values? What would be the third midpoint for the unique values? So you need to look here. You need to go, huh? Uh-huh. Uh-huh. What would be the third midpoint? Be the third midpoint for the unique values. What would be that third midpoint? We can check it. We can get the answer. That's the third unique value. So that's the third unique value. What would be the third midpoint? So it would be the third midpoint. This is the third unique value, but what's the third midpoint? The third midpoint would be 3.3. Just take a look right here. Good guesses, everyone. Carly and Jordan, you guys are doing amazing, guys and gals. And so 3.3 because it's between these. And this tells us the mid value right here. So what is this solving for? It's solving for the between number between all these so we can split them up. So the whole point of this is to make midpoints and to be like, okay, between these two numbers, between these two numbers, between these two numbers, just going through getting all the midpoints. So there we go. And we're going through store into the ith element of the improve, the fraction and the reduction in this right here based on where we did the midpoint, where the data frame is just that, right? Okay. So this is the data frame right here. What you could do is you could take and just call this df, and that should do that. So, and let me drop that code in the chat. So all we did was store the census, the only two columns we want as the data frame. Go back to earlier today. This was a big thing we coded out right here is we made a function called improvement. And the improvement function will allow us to see the improvement at different points. Like if we give it a data frame and then we do this right here. So what are we going to do? We're literally going to take our improvement function. And then with the improvement function, we're going to go into here and we're going to have it produce different values of the threshold. Am I on the right one? We're going to put this right here. And then we need to go here. And this is the threshold. So let's go threshold. Put this right here. And that's what's going to change. We're going to store into the threshold this. And then the data we're going to use is the data frame I created right here. And I think we are about good because now all we need to do is grab our improve element and store into the position right here. And that should do it. I think that's everything for this. So that, really? Ooh, that, you see? I was like, it shouldn't be that quick. So where is the error? Where's the error is the question. Did it even run? And so let's call this place. Well, no, then we'll have to rename it. I don't think that's the issue. Let me see. Let me take the code out of the loop. For I in, okay. So now we're going to take the code out of the loop. Because if something goes wrong, you take the code out of the loop and you run it without. So we just look at what the loop would do. So this is key. I'm getting an error eval object xvar not found. Ooh, that's, go back to, Jordan. Yeah, so I was right to change it today. Do you see how I have this written, Jordan? Let me drop some of these in the chat for you right here. You'll need to change to this format. I was thinking through it. You need to change your, do you see where I have this right here where it takes the second column and the first column? And I think this should work right now. Ooh, this is, wait, that's fine. No, this is the issue. I think this is where the function is not working. Data $y variable. You know what you could do? You could just rename the columns at the start. It's like the easiest way to do this. The data $y variable is a problem though. That's an error in the code because this won't work on everything now. We need to go to the y variables in the first column, and I don't see any other y variables. That literally might be the only issue. Let's see if this works. It is working. Let's go back down to our for loop. That might have been the issue. Improvement. It's storing it for the last one, which is interesting. But it's getting NAs for all the other ones. Threshold should be Ooh, ooh. Did it say thresholds? Oh, oh. Yeah, that might be it. That might be it. Wow. So, oh, wait a minute, wait a minute. So thresholds. There's a lot of ways to do this, and I'm like, where is the error? I don't think that's gonna fix it. Nope. Let me see what the loop's doing by running this right here. Okay, wait, let me remake the improved vector and then take a look at this, because let me see if it's writing the first one in. Okay, it writes the first value, and I think this is where the problem is. So it did the first one. What? Okay, wait a minute. Are you haunted R? You gonna do it? You gonna work the right? You gonna do the right things here now? So let's comment out our code right here, and let's see. Let's run this. Okay, good. I'm not happy it didn't run, but can we get the NAs again? So let's see right here. Let me uncomment out this code right here. Okay, uncomment out the code. Let's run this chunk right here to reset the vectors. Let's start with the first. And that does that. And see, it is adding. Does everyone see it is actually working? So it's actually working right here. And then we have to think, why does it not work in the for loop? Do I not have the exact same thing? For I, in length... One moment, everyone. Be right back. It was the least exciting delivery ever. It was a fire extinguisher. So it was super not exciting delivery. They're like, "Here's your fire extinguisher." I was like, "Oh yeah, thanks." I opened the door just slightly. I was like, "Here, just drop it." He's like putting his hand through. He's like, "Just don't shut the door on my hand." So I got a fire extinguisher again. Yay! I know. It's like everything's fine. See, look, he heard us. He heard everything was burning down right here at this example. Why is it putting NAs in? So let's just think through this. The vector it goes through. Oh, really? Is there a typo? I see it. How many times does my for loop run? How many times does my for loop run? 10,000 point question. I don't care. I'm throwing huge points on this. I see it. I know exactly what the issue is right now. Because the code inside the for loop's fine. And I did a mistake that I'm just like, really? I haven't done this mistake in forever. I made a mistake that's just very basic. And then I looked and I saw it and I was like, oh, that's why. One. Code root, yep, and you added the extra thing on it. Right now my for loop runs one time and we have to be careful. It does it. I always remember that does it. Yeah, that should do it. That should fix it. Because now it's going to run this many times. It's going to insert those numbers. You know what you could do is, I just saw this because I've been looking at code today. Literally what I do in my spare time is I just look at code. Watch this. You could go sequence of length of, what is it called? Unique X. You see, this looks even longer. Why am I doing that? And then you'd put the minus, wait, unique sequence. It's called that, right? Yeah, there it is. Sequence of length of unique X, and then -1 right here. That should do it. And so this should go to 846. That should do that. Yeah, it goes to 846. Now you're getting longer object length is not a multiple of short object length. Let's see if I get it. Let's see here. Dun, dun, dun. Okay, it looks like it did something. Ah, did it. We got it. Post your code in the chat, maybe, Jordan. Is your function working? Is your function, do your function on outside the loop right here. Do it outside the loop first. Make sure it's working on the data frame. And of course, comment out code that's not being used. Like, you can keep this in your work. I would just, if I'm going to submit this, I'm going to go to this code and comment it out afterwards. Ooh, you got to watch out because you're going to need that DF right there. You don't want to comment that out. You want to comment that out. Because you need to store the data frame in there. Watch what you comment out. That was just our practice code. Like, that's just practice code. But which error are you getting, like, on, where is it being like, no? Where is it? And great job, Jordan. These are tricky problems. As you know, it's like, once again, I said, I've been coding a while now, and I'll still just be like, well, oops, it doesn't run. And then we just got to figure out where it doesn't run. It wasn't the code inside the loop. Because, like, the code inside the loop does what it should do. Here we go. Let's take it. Let's figure out what's going on right here. So if this works, then it's got to be the function from earlier. Yep. And that should be good right there. So if this works, Jordan, it's the function from earlier. So let's narrow down the problem. You ready? That's going to store the data frame. It's just putting it here so we can just do a kind of a shorter abbreviation on it. It's just easier to work with. Thank you so much, Jordan. Great job right there. See, if someone was quick, they'd be like, boom, got it. Okay, so we're gonna, because it put the spaces, we're just gonna make this look nice and neat right here. It looks about right. We'll find out what happens. Okay, we're gonna clear out our answers just so we can, make sure we have like the thresholds. There's nothing in there. The improve, there's nothing in there. We're gonna run this. We're getting the error. It looks like good. Wait, there's 50 warnings. Oh wait, it looks like we got it. Okay, so with this, Jordan, the error has to be on your, I think this is the right thing right here on the improvements. And we could graph the improvement. I wonder if we just go to, should be able to see. Whoa. Here's the improvement. You can tell about where the best improvements are. So this is where it's choosing to cut, and the better the the higher the reduction, the better the improvement. So it should cut somewhere in here. And it's just kind of, man, patterns in data are so cool. Why wouldn't we divide the thresholds by 2 anymore? Wait, so a good question. Why wouldn't we divide the thresholds by 2 anymore? You are getting this? This should be correct right here. Was it? I think everything's working then, Jordan, right? I don't know what the error is. And why wouldn't we divide the thresholds by 2 anymore? The reason we're dividing these thresholds by 2, which we are dividing the thresholds by 2, the threshold is kind of like where we're going to split between. So where we split between is between 2 unique values. There's other ways of doing it where you could just say like 3 and below or above 3. But if there's like the number 3 and 4, we could split on 3.5, which anything below 3.5 would be this. It's really just a lot better to not have the unique value in there because it's like below 3.5, above 3.5. And if it's like integer data, does that help answer, Carly? I'm trying to make sure. You did yours? Oh, and you did mean, yeah. Oh, I did? Oh, yeah. Oh, and Jordan noticed that. Yeah, I didn't even notice that. Yep. Oh, I see what you're saying. I thought like, yeah, it's synonymous code. Great job, you guys. Great job, Carly. Another 1,000. And Jordan, thank you 1,000. I appreciate you guys because I want you to be like, wait a minute. Well, I didn't even notice it. I was like, it runs. So Jordan used the mean function and I divided by 2. So as long as you, and yeah, the mean, oh yeah. So, oh wait, Jordan, I think you have an issue, Jordan. I think you might have an issue because, be careful. I think there's an issue with your code. Carly just might have pointed something out. I think, Jordan, you want a code that looks like... Yeah, we found an issue, Jordan. You want to change your code just slightly to this. Does this make sense, Jordan, right here? That you want to change this code, Carly. Carly, you're at 10,000 like Jordan because you just found an error without noticing. I mean, like maybe you noticed it, but you're like, hey, something's different here. And if we hadn't pointed this out, Jordan's answers would be slightly different. And we can show, here, we'll do this real quick. We'll run mine. And I'll show Jordan how to fix his code in a second here. And then if I plot this, we should see it change just slightly. Hopefully it changes just a tiny bit. Whoa, it changed majorly. Whoa, that was a major change. Jordan, it's a major change. So what we want to do is inside of this, here, let's change this to a comma. So no, I appreciate it. I mean, it's all those little things. We're just going to take this for a moment and we're going to concatenate. And now it's taking the mean of those two objects. So yeah, no, this is what it's all about. It's like, hey, why is this like, because I didn't see it. I was like, it ran. And so what was the difference? Here, we'll look at the two things side by side. Here's the old code. Well, that's the current code, excuse me. Here's the previous code. So this is taking the mean of how many objects. How many objects is this taking the mean of? How many objects is the first code taking the mean of? How many objects is the first code taking the mean of? It's only taking the mean of 1. Yep. I like it real fast. 1. And so it's only taking the mean of one object. It's taking the mean of 5 plus 6. And it might sound, and don't worry, like it took me a moment. I was like, ooh. But that's taking the mean of 5 plus 6, which is taking the mean of 11. What's the mean of 11? If you have one observation, what's the mean of 11? The mean of 11 is what? Anyone know the mean of 11? The mean of 11 is 11. So it's only one observation it's taking the mean of. Like you could add something else here and you could do this and now it's going to give 21 because it's just taking the mean of 21. It might as well just have in here 21 and it will just tell you 21 because that's the mean of one observation. So 5 plus 6 has a mean of 11, but we're not doing the sequence of numbers 5 plus 6. To vectorize those numbers, we have to do C, and now we're doing what is the mean of the sequence 5 and 6, which is, I mean, it's a sequence. It's a vector, and now that's 5.5. So that's the average of 5 and 6 right there. And this graphic behind me is the graphic you should get. So great job working together, seeing where it's so easy to make a small error right here. And yeah, it's just the smallest of things. Change code dramatically. Changes dramatically. A plus or a comma. I like it right there. Any additional questions? Really great work today. I'm so happy. I'm so proud. Like Jordan, Carly, how do you feel about your coding skills now going from 320 to 474? And this is what John, I think I can say his name. His name's John. There's about 1 billion Johns. But John's sending me the COVID data stuff right here. You look, it's even got the data on it. Really good organization. So I guess it's a little behind. Oh, I could see how it worked. Let's try this. Okay, let's shut down our 20. Okay, we should be able to. Let's see. Don't save. Oh, I maybe I should have saved. Let's reopen R. Let's see if it works. Yeah, Carly, it's just practice. It's just practice. Did you have 320 last semester? It's just practice. You just get better with time. And the better you get, the more you can go to a company and say, yeah. And so it's just practice. You just have to be like, why does it do this? What's going on here? Explain this. You got to ask. I mean, that's the one thing I've been learning over time is like, when you're stuck, just ask. Because you'll ask less and less questions as it goes on. But if you, one of these days you might hit that floodgate. Like you might just be like, I've got 1 billion questions. Okay, let's set that working directory. We got to run all this right here. We're loading up the libraries. All the libraries loaded. We're going to go to set working directory. We're going to see if we can end with this today. Go to downloads, open downloads. Okay, we set our working directory. Okay, this is going to download the file. The file has been downloaded. It's working on my other computer. It completely works. And I have readxls, or that's readxl, but readxl, and it's on. I don't know. I literally went when he sent this to me. Did I change something in here? Did I change something? Yeah, let me hop over here. Let me see if because I'm going to reload this the whole thing, because maybe I changed something. Let me close this out. Oh, I see I overwrote it. I really want to take a look at this. It's so cool, and I have no idea why it wouldn't work. So give me 2 seconds. Let me... Okay, let me re-download it, because he sent me the file, and I pulled it up on the Mac, and it worked perfectly fine. And there it is right here. Okay. So Let's go ahead and run this right now. Let's run it from all the way down here. It looks like it's running. Really? Now, why would it work on a Mac and not a PC? That's the big question. Yeah, yep, we did the improvement. Look at the end of today's lecture. We did the improvement function. Email me if you're stuck, Carly, and we can work on it tomorrow. We can work, if you're stuck, and be like, hey, Brian, help out that. And I can show it. Here, I'll talk about it here real quick. Ask questions. It's so weird. Maybe they took it down. You know what could have happened? Like in the time between, maybe I'll try running it on my Mac, but I literally have this on my Mac and it's working. I'm like, why are you bombarding our site? It downloaded a file. So weird. Well, it works on my Mac. That's what matters, is the Mac works. Let's look at that homework right here. So we have this in the earlier video, but feel free to ask questions. So here, I'll walk through this right here, Carly, so feel free to listen up, and this is how it works. So when we're computing the original sums of squared error, what we're going to do is we're going to go, this is the one where we didn't change it. This needs to be the y variable right here. So this needs to be the y variable. So the y variable is the first column of the data. So someone gives us data, we go to the first column of the data, and we subtract the variable from the mean, and this gives us the error. Now, what we're going to get is the sum of the squared error. So this is the sum of the squared error right here, and then we're going to do the exact same thing for where we do partitions. So this process right here is merely what we're doing to start, is finding the error within the y variable. And what do we mean by that? I think I still have some stuff up here where I was showing how to do it from earlier. We have here a y variable. Oh no! Jordan, I didn't look at the sorry, I created that model and I never looked at it, and I'm really bummed by that. Okay, sorry for, I gotta make the custom again. Okay, it's gone. Just so you know, Jordan, I don't know if you're here at the start. Sorry, Carly. We got the custom tuning to work, and here it is right here. Let me store the custom real quick. So what it is this custom tuning that I found. If I go down here, and I should have it stored. Oh, did I not? Let me bring this up. What we can do right now is we can take our data set and we can create a custom, here, we'll do this right here. This, yeah, we'll do this. And let me run everything above it. Okay, that should be good enough. It should create everything. And what is it not like? Oh, there's a comma right here. And so now that's creating cool. Okay. So what this is right here with the custom fit is this right here allows us to fit on the number of predictors and also the number of trees. So we can choose the number of trees for this model and the number of predictors, which I kept saying in class. I was like, I know we can tune the number of trees. I've done it. I was like, I know it. It's like with ROC again. I'm like, I've done this. I know it. And all we had to do was create this custom fit code right here. So if you look right here, this creates the custom fit for us. And now with this custom fit, we use the custom fit object right here, and then we can plot it and see the different levels. And I had created that in the background, and I forgot to show the results because I actually made a really nice grid on it with a lot of values, and I was really excited to look at it. See, that's the thing, is like, if you like coding, you're like, I want to see the results. And we'll never see those results again. They're gone. Good. Yep. Awesome, Carly. Awesome. I'm glad. Did I know I jumped around on that for just a second right here? Does this make sense right here, what's going on with the threshold with testing the data while I let my custom random forest run in the background with the different tuning parameters for the trees it's going to have in the forest, the amount of trees, and the number of predictors that'll be in each tree from the bootstrap random rows? A lot of this, if you can't tell, the code is very similar. It's the concepts of what are we doing that matters. Like, you can tune the number of trees, which I'm going to tune right here. You can tune the number of variables that are used to make predictions. Y tilde x comma data equals. Method is the specific type of thing we're doing. TR control equals fit control, controls the validation. Tune grid equals random forest grid. That's this right here. And pre-proc center scale makes everything z-scores so that they're on an even playing field. And we have to know what the code does. Where does the threshold come from? So the threshold is the way that these trees work, and what this question is trying to show to you is the tree tries to split. Oh, we deleted our plots. Do you remember that graphic we saw just a moment ago? Let's bring this up in the background while we do this. We saw a graphic a little while ago that looked like this right here. So the graphic we saw looked something like this. And what this is trying to do is trying to make an improvement in the sums of squared error reduction. So what we do is we compare how much the sums of squared error was to how much it currently is, and we try to see how much we've improved it. So we're trying to improve the sums of squared error, and our goal is to reduce the sums of squared error, much like 320. So this right here is improvement, basically. We can just put improve right here. So where will this choose to split? It'll basically go to the highest point. Wherever the highest point is where it'll choose to split. And what's down here is everywhere it could possibly choose to split. And what do we mean? Well, if you were to look at data, a very small data set, like a data set with this right here. Here's a data set, and I want you to tell me how many values we can split on for this data set. How many values can you split on for this data set? I mean, this is a decent test question. How many values can we split on for this data set? It's tricky. I realize people might get this wrong. Don't worry if you get it wrong. How many values would the algorithm choose to look at to split on? And so think about what the code did, what we wrote. We wrote unique, close, and I did a trick in here. I did a trick. If it was 1, 2, 3, 4, it'd be 3 values. But because there's the same repeating value, you'd have an answer here, and you'd have an answer here, and the values we could split on would be 1.5, and that's why we're averaging them, and 3. And so this is where we write the code where we get the unique, like we take all the unique values. So we've got unique value, unique value, unique value. And then we go between the unique values. So when you look at the average of the unique values, that's what we're doing right here is by taking the unique values, and there's 3 unique values, and then we're going between them by averaging them. And so we also don't go beyond it. If you look at how the code's written, it just goes through all the unique values, and then it stops before the last one because it would escape it. So the code has 1 minus because it starts right here and compares this to this, and then it compares this to this, and then it doesn't go to the last one. That's why we do -1 at the end, because if we went to the last one, it would be this to it wouldn't have it. So I guess it might make more sense if I draw it. Yeah. So yeah, no, I think the visuals can help. Like, what is the code doing? It's finding the average of those numbers. So maybe we could draw this a tiny bit better. But this is what we are theoretically doing with this problem. And so I never want people to think of this as like, well, we're just writing code for randomness. No, we're writing code to do a procedure. And the procedure is finding the unique numbers, finding the middle number, and then it's going to split the data set. Be right back. Well, let's take a look at our random forest to end off right here. And let's go ahead and plot this. And we made the forest fit. And boom. Here we are. Guess what we just did? Jordan, if you're still here, and Carly, I think Carly's still here, definitely. We now tuned on the trees. We not only tuned the M-try, but we tuned the trees. So as we said today, you're back, Andrew, look at this. We have tuned the trees, which you might have been here at the start when I was saying, we can tune the trees. I swear we can tune the trees. But then we broke the COVID code. If we fix one thing, we break another. That's the rules of the game. So fix one thing, break another. So we have tuned the trees, and I'll try to post this file here for everyone to see, but that's got it. Good job, office hours. If you have questions, email me. Talk to everybody later. Bye.